All right, folks, here's the deal. I made a mistake and I'm restarting, but that's okay. We're talking about slope-intercept form, y equals mx plus b. This is the one that you will see mostly in high school. There are other forms, and we're going to talk about them. There are different ways to talk about the same thing. They might talk about a different attribute of a line, but this is the one that you see most of the time, y equals mx plus b. All right, y equals mx plus b has m, which represents our slope, our rate of change, and b, which represents our y-axis, our y-intercept. So notice, if I push this, b, as it goes down, the line moves down. As b goes up, the line goes up. It's going between -10 and 10. Notice if I pause at negative 9.48, this line crosses the y-axis at negative 9.48. That's all that b does in this format. Now, m, on the other hand, m tells me how steep I'm making the line. It makes the line go up or down and makes it go steeper. So if I can describe where the line starts on the y-axis using b, and how steep the line is using m, I can describe any possible line. So notice if it's 0, that's a straight line, a flat slope. If it's positive, that means the line goes up and to the right. If it's negative, the line goes down and to the right. That's a negative slope. And that's all you really need to know right now. M will always represent slope, how steep something is. So we'll learn other forms, but M will mean the same thing in the other forms too. But yeah, for the most part, we're going to talk about this in form of like word problems and stuff. So you won't be dealing with too much stuff. But what it boils down to is you need to be able to turn y equals mx plus b into a graph, or graph back into y equals mx plus b. That will be a quiz. That will be on the test. All right, so you're doing this assignment, page 135 in the book. It has many more pages than the last thing we did, but it's a less explainy too, so we'll get there. I recently, instead of backspacing, pressed the power button, so you can see that I started this and I'm restarting, but I'm going to leave these here. Here's things we need to know. Rate of change, that's how fast something changes. It could be the speed of a car, or how fast that you are able to knit a sweater, like how many, I don't know, knitting patterns you can do in a certain amount of time. It has to do with the speed. Okay, now speeds can change. Your car can change from 60 miles an hour to 20 miles an hour. So that's change of a rate of change. And that's where we get a little confused. Remember, rate of change is like a speed. If we have a constant rate of change, that means the speed of your car is not changing, because constant means to stay the same. So you can have a rate of change that does not change, which can be confusing to some people. But just think about it. You're driving 60 miles an hour down the highway, and you don't speed up or slow down. Your speed is not changing. That's what we mean when we say constant rate of change. Okay? All right. So whenever you have a constant rate of change, it makes a linear function. A linear function has a constant rate of change. It forms a straight line, like this. When you talk about how steep something is, it's the slope that we use to refer to that. Slope talks about the steepness. It is also technically the rate of change. Slope and rate of change are the same thing. Since the curvature of the graph is not changing steepness, rate of change is the slope. All right. You can describe slope with a decimal fraction or an integer. I'm just going to tell you up front, fractions are our friends for slope. You can use the other ones, by all means. But generally speaking, we like fractions, unless they simplify to make an integer, okay? But yes, they will also use decimals in this book, and we'll use that too. Decimals are just fractions with tens in them, when you really think about them. Okay, so use the point 0, 1.5, and 10, 12 to find the slope of this line. We've done this before. We did this in the last one. This is the float of the car and the gas tank. We just did this. To represent relationship between G, the number of gallons in the tank, and H, the height of the float. Okay, so we're going to start using a new thing here. We're going to use delta regularly. They definitely use it for this book. So we're going to try to figure out how much one thing changes compared to the other. So they told us what is the x-axis. Remember, we always put y over x when we're doing slope or rate of change. Y over x, y over x, y over x. Remember that. So my x-axis is float. H for the height of the float. And my y-axis is gallons in the tank, G. Now they gave us the points here already. 0, 1.5 is right here, and 10, 12 is right here. So they're trying to save us some time and make sure that we can really read the graph and don't get like thrown off by that. So that's nice of them, right? Yeah. But just so you know, it's not something new that they came up with. These points are on that graph. And if you need to remind yourself of that, take a moment to remind yourself of that. So how much did the height of the float change? That's here. Well, it changed from 0 up to 10. From 0 up to 10. That's 10. It went up 10. Okay, let's change colors for the other one. From 1.5 up to 12. From 1.5 up to 12. How far is that? Well, that's 10 and a half. I did that backwards. How did I do that backwards? My goodness. Ugh. Okay. I said y over x, and then I continued to put x over y. I don't know why I did that. I'm sorry. We're going to fix that. If you were confused, good job. If you're not confused, I apologize. Now you're going to be confused because I screwed up. I'm going to have to erase it and redraw it. Okay. So we're erasing the h and the g. We're going to put them in the fraction correctly. Everything else is right. We were keeping track of gallons and height and all that fun stuff. But here's what went wrong. I put the numbers in the wrong spot. Oops. Wrong color. So we have 10 on the bottom because that's our x-axis. And we have h on the bottom. G is on the top because it's our y-axis. That's keeping track of gallons, 10.5. And so the slope is, well, it's just how much y changes divided by how much x changes, which is 10.5 divided by 10, that's 1.05. And that's good. Let's circle that guy. Oh, that's a great circle. Okay, and I was just really quickly going to go like this too. Change in y, change in x. That's how we find slope every time. Okay, so now we got these things, triangles and quadrilaterals and diagonals. This is really fun. You might have to do some of this on your own. Here's what we notice. Diagonals go from one corner to the other corner of a shape without touching any of the sides. So if I go from one corner to another corner of a triangle, those are the sides. So there are technically no diagonals in a triangle because I can't draw a line diagonally from one corner to the other. Okay, this is a thing you do in geometry a little bit. It's not terribly important to understand diagonals in this class. It just so that we understand this problem. Okay, so if I want to draw diagonals into a quadrilateral, wait, number of sides and the number of diagonals that can be drawn from one vertex. Okay, I wondered about that. They're going to keep it simple by saying from one vertex. So if I start on one corner and I cross, that's one diagonal from here. Of course, I can do another one from another corner, but that's not what they asked us. Okay, so now if I do one diagonal from here, hey, I can do 1, 2 of them from here. And this one, I can do 1, 2, 3 of them. And if I had a heptagon, 2, 3, 4, 5, 6, 7. Then I could go with 1, 2, 3, 4, and so on and so forth. Okay, so you can figure it out, the pattern, if you'd like. I'll give you a second and pause. And now I'm back. So what is the pattern? Well, here's 7 heptagons have 7 sides. If I start from one corner only, I'll always end up with 4 diagonals. I have 8 sides in an octagon. It means I can draw 5 diagonals. I have 9 sides in a nonagon. And I get 6 diagonals from one corner alone. And if I have 10 in a decagon, I have 7 diagonals from one corner. Okay, we're going to graph this to information, and we'll do it like this. We don't have negative sides, so we're going to have sides going down to 0. I'm going to go like this. Oh, I hate it when it does that. Control Z. So I'm going to make this line go 0, be way over here, because this is going to be sides. Because that's what the sides, how many, and this is how many diagonals we can have. Okay, I know I'm just diving into what is a diagonal. It's not very important to really understand what that is right now. That's a geometry thing. You will learn it next year, and we're going to drop diagonals right after this problem. So it's not important to really focus on it. It's just how many times I can draw across. And I hope you can see this pattern. All right, so we're just doing that. And now we are going to notice that the number of diagonals starts at 0 and goes up to 7. So let's make sure there's 7. I'm just going to go from here. Now, I didn't make the X be in the center. That's because I can see more this way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so if I have 3 sides, I get 0 diagonals. That's right. 3 sides, 0 diagonals. Let me make this bigger. I'll make it 6. 3 sides, 0 diagonals. And then if I have 4 sides, I have 1 diagonal. 4 sides, 1 diagonal. I know this is weird. This is 1, 2, 3, 4. You know how this stuff goes. I hope that you're able to read what's going on with this. It's just like a regular graph, only I zoomed up to the top right corner. I don't have the X of the X-axis and the Y-axis crossing in the center of the graph. That's all. So green one goes there. Go with pink. 5 goes with 2. And if I graph them, I'm going to graph the rest in black, because it should make sense now, I hope. 6 goes with 3, 7 goes with 4, 8 goes with 5, 9, and 10. These are our points. Notice they make a straight line. Oh my gosh, that should be, what is that called? A linear function. That's right, a linear function. So I'm going to go back to here, make a black line. I'm going to start it way up here, because I can assume that the pattern keeps on going. And I get a graph that looks like that. Very good. All right, so that's our graph. Okay, what's the general trend or flow of the data on this? Indicate what trend in this trend on your graph from question 7. I already did that. Now they said to make they graphed the data. We put the dots. And what they want us to do is I put a line in. Okay. Now there are reasons to avoid lines. And we're going to talk about some of them because some of this doesn't make sense on this line. Okay, so think about what's going on, how many sides the shape's allowed to have, how many diagonals it's allowed to have, and think about why I would not necessarily use a line to describe this. Okay, so what we're going to say is, here's a trend you probably noticed. When this goes up by 1, that goes up by 1. Number of sides goes up by 1, the number of diagonals goes up by 1. So we'll say that when the number of sides increases by 1, so does the number of diagonals from one vertex of the shape. Now I'm using lots of fancy words. Again, this is not a big deal, but vertex is a corner. That's where the lines come to, where they meet. So this is a vertex. That's another vertex, another vertex. Cool words for very basic things. Okay, so we're starting at one corner or one vertex. All right, so vertex, cool word. We're indicating it you can see this pattern because the points on the graph form a line. Filled in the line. Great. We already did that. They make a line. We filled in the line. Okay. Now we're going to find the slope. Well, there are two ways we can find the slope. We can find it by looking at this. This goes up by 1. That goes up by 1. This goes up by 1. That goes up by 1. 1, 1, 1, 1. Or I can go down here and I can say this goes up by 1. That goes up by 1. Or this goes up by 4. That goes up by 4. So we're going to take the change in y divided by the change in x. Oops. Notice I draw my x arrow pointing to the right because I don't bother to go to any other direction with x's. I keep track of whether y goes up or down, which it goes up. And x is always going to the right, which is its version of up, I suppose. So when we find our slope, we can say the big thing we need to know is sides are x and diagonals are y. Sides are x because the number of sides in the shape affects how many diagonals you can draw. That's the way the question was asked. And x is always the thing doing the affecting. So we're going to talk about our slope. 1 should look like this. Yeah, I thought I chose red. So, well, I put them in the wrong order again. Wow, I'm just on a roll. I just said sides goes on the bottom. And I am back. I keep accidentally typing the backspace is right next to the power button on this computer, and I turned it off. Okay, I was saying sides are x, x goes on the bottom, diagonals are y, y goes on the top, so I need to put diagonals over sides, not the other way around. So okay, so we know that the slope of this line that we're graphing, is, well, it's 1. 1 diagonal per side. I'm going to say diagonal added per side added so that we can understand what we're talking about a little bit more. And our y-intercept Our y-intercept is all the way down here. Where is it? Well, it's negative 1, 2, 3. Often we'll just say negative 3 for the y-intercept, and that's perfectly okay. So here's the thing. We're going to use y equals mx plus b now. Y equals mx plus b. I want you to understand this is a shortcut. Okay, we just figured out the graph. We could kind of put in numbers and we could come up with a formula. It could take a long time to figure this out. But we just said at the beginning of this assignment that y equals mx plus b can describe any line, including this one up here, using the steepness or the slope, and b is the y-intercept. We just figured out the slope and the y-intercept. So m is the slope and b is the y-intercept. Okay, so, all right. So what does that mean? I'm going to take my slope of 1, a y-intercept of negative 3, and that's going to create the thing. I'm going to put in, and my slope was 1 plus negative 3 plus negative 3. That's the same thing as just minus 3. That right there is a formula for this graph. Put the negative 3 in, and I put the 1 in. Notice the y and the x stay right where they're at. That's all. That's how we use this slope-intercept form. What does that mean? That means if I go to Desmos and I type in this right here, y equals 1x minus 3, let's just try it because why not? Let me put this there. Here's Desmos. Y equals, we had 1x minus 3. Okay, we'll do it a tiny bit. There. Here's my graph. I'm going to scoot it over here a little bit so it looks closer to what we had. Here's our graph. Here's our graph. Here's our graph. Here's our graph. This one crosses at negative 3. This one crosses at negative 3. For every one that this goes over, let's zoom in one more so I can see. For every one this goes over, it goes 1 up. For every one this goes over, it goes 1 up. Oh my gosh, they're the same exact line because we just learned how to express a line using y equals mx plus b, slope-intercept form. This is called slope-intercept form because it tells us the slope-intercept. I should say that. Y equals mx plus b is called slope-intercept form because it describes a line using the slope and y-intercept of the line. Why? Okay, that's an important thing to understand about that form. That's why, slope-intercept form. Okay, we're going to use our function rule to answer the next question. Now, just so you understand, not all of these points work. What does this point actually even mean? Just for the record. This point down here says, if I have 0 sides to my shape, how many shapes do you know that have 0 sides? None, because Nothing has 0 sides. It's literally doesn't exist, because if it doesn't have sides, what would it even have? Could that have diagonals between the sides? No, it couldn't. In fact, mathematically, this says it would have -3 diagonals if it had 0 sides. That gets into crazy theoretical land. And there is a place in math for that. But for the most part, everyone else says, hey, we probably shouldn't even use a line to describe this. We should probably just use dots and start here. And that would be a more realistic way to describe it. But since we're practicing making lines and graphing lines right now, great, we'll stick with this. But yeah, just wanted you to know, if you're confused by that, you're right. Now they're going to ask, how many diagonals are in a 20-sided polygon? Now you could count up and figure it out, but we just came up with this function that describes this pattern. So if I just follow this line up until x is 20, and I have 20 sides, that should work. So in other words, I can take this, and I can just say, what if x is 20? What if there are 20 sides? And I can use this function to figure out, what does y represent? Well, y represents how many diagonals there will be. X represents how many sides there will be. So I can just use this formula I just found to solve this problem. All right, so let's do that. Y equals 1x minus 3. What does that mean? Well, 20 is x. So remember, x equals 20. Why? Because we said way up there, x is sides. X keeps track of how many sides there are on my shape, and this shape has 20 sides. So x is 20. So that's going to be y equals 1 times x. Well, 1 times 20. That means y equals, well, 1 times 20 is 20, minus 3 is 17. 17. Actually, I should do this real fast. If So I'm just gonna, I was typing, so I didn't talk while I typed. But here's our answer. We just plugged in 20. We got out 17. 20 minus 3 is 17. And that means that if a polygon is 20-sided, it should have 17 diagonals from one vertex. And we just talked about this next question. What does 0, -3 mean? Well, that means, well, x is sides. A 0-sided shape polygon. Regular polygon, technically, but that's okay. 0-sided polygon should have -3 diagonals. Now, what could I do if it doesn't make any sense? Well, something I could do by setting a domain and range. Remember those? Three or more sets. So what does that mean? I'm typing rather than talking and then typing slowly. So remember, domain and range tell me what x and y could be. So I could say x has to be bigger than, well, x is the number of sides, has to be 3 or bigger. X is greater than or equal to 3. Oops. So y would be greater than or equal to 0, which is why they started with a triangle. That means a 3-sided shape should have 0. That's where we start. So really, this line should, just as a matter of course, if I were going to be honest, I would not use this. I could still use that to the function, this rule to describe the line, but I'd have to say, but it really starts here. The line really starts about here. It goes like that. But there are still problems. Could I have a 2.5, a shape with 4.5 sides to it? Not really. So the line in general is just a bad idea, but that's beside the point. I'm talking too much. What are the domain and range of this? Oh, what did we just say? Right there. But I would go even further, because we just said you can't have a 3.5 sided shape or 2.5 diagonals. You can't have decimals either. So rather than just saying x has to be bigger than 3, I would say domain x is a counting number greater than 3 or greater. And range, y, well, if x is a counting number, so is y. Y is a counting number 0 or greater. That's just kind of describing what we talked about. That's the table right here. The 3 and 0 and works up. It can go on forever, but it can't go down. You can't have negative sides. You can't have negative diagonals. That makes no sense. What are the domain of the range of the function that expresses the number of diagonals in a polygon? Y, given the number of sides in the polygon, x. I'm misunderstanding how they asked this because I'm new to this text, my friends. This right here is what they're looking for here. Boom. Okay. I'm going to erase this. I'm going to make the line longer. Why? Because this is actually talking about diagonals and things. That's what we're talking about, right? Given the number of sides and all that. But if we just have this as a standalone function, what they're really looking for is I could plug anything in for x. I'd get anything back out for my y or my f of x. So if you remember, we use the term all real numbers to say you could plug anything in. I can make x be 2 million, and then the other number would be 2 million minus 3, 1,999,997. Good times, okay? Yes. So there we are. Sorry about that. Okay, we are halfway through. Okay, Alejandro borrowed money from his grandfather for a down payment on a car. He told his grandfather he would make weekly payments until he repaid all of the money he borrowed. That's nice. Alejandro made this table to represent the amount of money he still owes to his grandfather. Describe precisely what is happening to the amount of money in his savings account. Well, let's see. Every week he clearly pays some money, right? All right. That's interesting why they're calling this a savings account. But that's okay. Well, we're just going to ignore that. I think that it's actually a typo. So we're counting weeks in ones 1, 1, 1, 1. That's what we can expect. All right. And every week he pays a certain amount. And that's what he said, weekly payments. Great. What's happening to the amount of money he owes? It goes down by 50. And it goes down by another 50. It just keeps going down by 50s, doesn't it? Okay, it's good to check. 50, 50, 50, 50, 50. But I'm not going to write it because it takes forever. Okay, so this is going down up by ones. That's going down by 50s. In the table, can you see week 6? Yes, I can. Study the pattern in the table and then write a linear function rule that you could use to find out how much Alejandro will still owe his grandfather after 10 or 20 weeks. Okay, so we're going to do these steps that we talked about up here. We're going to find the slope, we're going to find the intercept, and then we're going to make a function. Okay, remember the slope is how much y changes divided by how much x changes. The intercept is the place where x equals 0. That's what you need to know. Okay, I'm going to write that right here. Slope, y divided by x. Intercept is where x, 0. All right, so that's how we're going to find it. The intercept's in there, and the slope is not too hard to find either because this changes by 50, that changes by 1. What depends, the amount you owe depends on how many weeks you've been paying. So this is our x over here. It's our x. This is our y. Just for the record, they almost always put y on the right side. There's not a rule about that. It's just how we like to write things in math. So I'm going to take, this changes by 50, goes down 50. Goes down by $50 in 1 week. What does that mean? Well, this is just going to say exactly what you would have said in the first place because it's not a hard math problem. Slope is down -50 per week. Dollars per week. In other words, he's paying $50 a week. Well, that's obvious. Okay. And now we need to find our intercept. Well, intercept is the starting point when x is 0. So intercept is 1,500. Or sorry, not 1,500. 1050. So what does that mean? Our function is, what do I hear? Y equals, we have our m is our slope, so -50. X plus b is our intercept, 1050. See how I just took those two numbers and I put them in there? That's it. That formula will tell me whatever I need to know. So 10 weeks or 20 weeks. Let's see what happens. Notice I don't know. I could keep going and find out. Or I could use this formula that I just created, this y equals mx plus b formula, to figure it out. So 10 weeks and 20 weeks, let's do it. 10 weeks, 20 weeks. Let's see here. So 10 weeks. If I had 10 weeks, that means that x is 10, because x keeps track of weeks. So I'm going to change x to 10. Y equals -50 times 10 plus 1050. And I go over here and I do the same thing only with 20. Y equals negative 50 times 20 plus 10. Okay, so that's going to be negative 500. Going to be you'll owe $150 because that's what's left. Here, 50 times 20 is 1,000. You'll owe $50. All that'll be left. Oh, phew, that scared me for a moment. We're still sharing, good. Yeah. So he'll be 1 week from done, 21 weeks, and he should have paid it all off. This is useful stuff. It's stuff people use. Okay, we're going to assume that the rate remains the same. Use your rule to calculate how much money Alejandro will owe his grandfather after 15 weeks. 15 weeks. Okay, notice 6 weeks, 15. It'll be somewhere between these. So it'll be in the $200 to $300 range, right? Okay, so let's find out. Actually, I think it will be $300. You can figure that out right here if you want to be fancy, but we're going to use our formula. So y equals mx plus b, but we have negative 50 for our m, our slope. It goes down by $50 every week. Mx plus 1050. Okay, this will seem magical. It's okay for it to seem magical for some of y'all. Okay, if it seems boring, it's because you've done it a lot. Okay, so let's use that. Y equals, we're going to say 15 weeks. We want to know how much he'll owe after 15 weeks. Let's do that. So we're going to make x be 15 because x is the weeks. Negative 50, 15 plus 1050. Negative 50 times 15 is going to be 750. Yep. Negative 750 plus 1050. You might be confused by this, so I'm just going to remind you. If I have a negative in front of something, that negative stays with the number. We have negative 750. So that means I could also, if this helps you, you could rewrite it as 750 minus 750. I'm just putting them together in the other order because they're just being added. Plus one of them happens to be negative, so it ends up that they're being subtracted. Okay, so let's see. If I take away the 50, that gives me 1,000. If I take away the 700, that gives me 300 left. After 15 weeks, he'll owe $300. A long time to pay something off, and it's not a house. So there you go. Houses take about 30 years to pay off usually. All right, make a scatter plot to show the data in question number 13. Okay, we're starting at 0, so I'm not going to bother with negative numbers for my x. That means that I'm going to make a graph that looks like this. It's going to have the y-axis be right here. Why? Because remember, that means that I'm counting 1, 2, 3. If the y-axis were up here someplace, the y-axis were like here, then I'd have -1, -2. The truth of the matter is that doesn't matter. That would be -2 weeks. Well, no one cares about that. So I'm not going to do it. I'm just going to have a graph that leaves out negative numbers entirely. That's the goal. Okay, so this is weeks. And this is money owed. All right. And we got to get up to 1050. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You know what? We're just going to say this is 1,000. 900. 100. And so on. 200. 3, 4, 5. There. That's good enough. I'm in a hurry, so you get the idea. You can number them better than me, and I'm okay with that. Just remember, it always has to count up by the same amount. If I skip a number like this, it's not like I'm stopped counting by hundreds. It's just that I didn't label it. That's different. It's good to label everything, but it's much worse if you skip a number. If I count like 100, 500, 1,000, no. Each chunk is 100. That's okay. That's what really makes this graph consistent. Okay, so now we've got this. We're going to graph some points. 1050, 0 weeks. What does that look like? That's 1050 is right here. 0 weeks is right on the edge. Should look like this. And then 1,000 during week 1. And 950 during week 2. And 900 during week 3. And 850 during week 4. Hope it gets to the end. There, look at that. There's our graph. Now, we can make a line. I'm going to do that, but just as a reminder, we're doing the line thing to try to remind ourselves what it looks like. This is another situation in which a line doesn't make sense. He's paying $500 chunks. He's not paying a couple pennies every second. No. It's not going down consistently like that. It's going chunk down $550 every single month. So using a line is a little bit misleading, but it also helps us kind of see, hey, there's a formula there. This formula right here, or if I want to use function notation, f of x equals negative 50 x plus 1050 at this line. And so as long as I just plug in counting numbers, I get the information I want and we're all happy. Okay, so we made our graph. Then graph the function rule, drawing points, yeah. So I think I was supposed to use this function rule and not that, but that's okay. Yes, but I guarantee you, I graph this function rule, it'll go through those lines. Okay, so this right here, this is f of x equals negative 50 x plus 1050. Okay, now we have this fun thing to simplify. I want you to see some things in the actual assignment now because it is confusing. Okay, so we're going to go back a page so you can see some things. So we got him, he's paying his money. That's really cool. We got this graph. Just want you to see what this graph looks like. We just graphed this formula, y equals negative 50x plus 1050. That's what we just did. And they're going to ask, move the slider to show how many weeks it will take him to repay his grandfather. They have a bigger graph so we can see it better. I can scoot this all the way over. Well, the amount he owes will go to 0 in week 21. So after 21 weeks, he'll owe $0. That's useful. Okay, we go on to the next thing. What if I want to know how much he'll owe after 18 weeks? Well, I make x be 18. I find that point. He'll owe $150 after 18 weeks. And so this graph is really helpful. I can plug in any number of weeks or any amount that I want to say, and that's useful. Now, the last thing they do is this fancy looking thing. And this is just to show you that the slope is the same. Okay, so in 1 week, it goes down 50. 1 week goes down 50. He can subtract these two guys, basically find out how much the y has changed here. And they can subtract 1 and 2 to find out how much x has changed. So this is how much y changed, that's how much x changed, just like we've been doing on our graph. It just looks scary. But remember, we subtract to find out how different they are. So this is basically the same thing as that. From 1 to 2, it changes by 1. From 1,000 to 950, goes down by 50. That's all that's going on here. They're just writing it with colors and stuff. And it's really fancy, and it scares you, I'm guessing, if you're a normal high school student. Okay, but just remember, that's just the table written in a different way. They're showing the points on the table. They're figuring out how much the y changed, 50. How much the x changed, 1. And they can find the slope that way. All right, so now we get on to the fancy looking thing. Look at this excitement. Now, I'm just going to tell you, this is not quite right, what they've asked you to do here. They're just messing with your brain. But I want to explain it because might as well explain everything that's in the textbook. So remember, there's some things you need to remember is y and f of x. They're the same thing. If I say y, change in y, that's the same as change in f of x. And so they're kind of interchanging y and f of x in here in a way that's very confusing. Okay? They're using f of x is over here on the y-axis, but they're labeling them f of x. And over here, they're labeling this y, even though they used f of x for everything else. That's because, remember, f of x, that f parentheses x, is interchangeable with y. It is just another way to write the same thing. Very important, okay? All right, great. Now we're going to simplify this fancy looking equation. Let's go here to kind of understand what they're talking about. We got this cool graph. We're going to say f of x plus change in x equals blah, 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 and all this fun stuff, okay? So what does this look like? I'm going to explain it on here, and we're going to type it rather than me writing all of this out again. So here's what we're talking about. When you analyze the graph of the previous page, you notice the difference in the slope is the same between any 2 points on the line. That's true. Let's go back and remind ourselves. This right here. I can move this to here. Now, this guy changes by 500, and that guy changes by 10. Still 50. I can move him over. Notice this number on the right, the slope, never changes. All I'm doing is I'm changing them both by a lot more. 950 and 19, still 50. So that's what we're talking about here. So let's talk about what that means. Oops, nope, I want to go to here. Simplify this equation. What do you notice? Okay, so we've got this right here. You can use the function notation to help analyze vertical change in y. This is a very typical thing we do in Algebra 2 and pre-calculus and calculus a lot. Okay, so we'll use f of x and x minus and change in x. What does that mean? Well, f of x keeps track of how high something is. So this one is at the height of the green dot. When I make x get bigger by a certain amount, that makes y get bigger by a certain amount. So I end up here. So this is saying this is the height of the point where I add some to x, which makes the point also go higher on the y-axis. That's basically what this is diagramming. There's nothing more complicated than that. They're using all of these fancy things to get you used to them. You can use function notation to help you analyze the vertical change y in this graph. The 2 points can be described by the coordinate f of x, x, y. Remember, y can be interchanged with x at this point right here. And x plus something, and f of x plus something. So that's right here. So this is the first point they describe right there. This is the second point they describe right there. So the change in y, how much this changes by, equals f of x, this height, minus that height. The top one minus the bottom one will tell me how far apart these 2 points are up and down. Ugh. Okay. And f of x in the equation, okay, use the function f of x. Yeah, you can substitute this and that into the equation to get y. Okay. So what are we talking about here? All right. We've got change in y, that's up here, equals f of x minus something. Okay. I see. So here's what's going on. We're going to mess with this, and it's going to be a weird thing, okay? All right. Yes, it's quite a fancy thing. Okay, just so you know, this is some messy math, but that's okay. Here's what we know. Y equals mx plus b is our formula, or just f of x equals mx plus b. All right, this will not go on a test either. This is a fancy thing to think about how we can kind of define slope. Okay, so we've got that formula right there that we've used, that we've talked about. You used it in 8th grade. We're going to use it in a weird kind of way. Okay, so what they're doing is they are taking this weird formula. Change in y is normal triangle. Yeah. The funny thing is, it shouldn't say normal triangle. It should say delta. Delta. They just didn't type it in correct or something. But then they're going to combine that with this formula. So if this is f of that, I'm going to plug that in for my x, mx plus b. And if this is f of regular x, then f of x is mx plus b. So what they're doing is they're taking this guy, and they're turning this into that, and this into that. Only for the first one, instead of a regular x, we have x plus triangle x, or delta x. So we end up with this. It's fancy. What does that matter? Okay, so I'm going to type that in there, and we're going to we get change in y. I'm going to type change in y instead of this, delta, because delta means change. Okay, that's going to be an important thing to note as time goes by. So change in y equals times x plus change in x. That's x plus b. All right, this is actually going to be pretty fast. What's going to happen is I'm going to do some distribution. You know what? This isn't going to work. We're just going to draw a triangle here after all. It just doesn't work with the actual algebra we have to do. I'm going to try to triangle of any sorts. No, that's not going to work. Okay, we'll just draw it in. Oh, wow, that's really not very I went to 0.1 instead of 1. I wanted 1. Triangle y, triangle x. Remember, that's delta. It means how much something changed. Okay, so we've got this. I'm going to distribute the m. I'm going to distribute the negative. That's going to give me this. Change in y equals mx plus change in x. Oh, m times change in x. B minus x minus b. Right. And this right here is what we call an algebraic proof. This is something you will do a lot more of in geometry. The reason we do this, well, actually, it'll be a lot easier in geometry than this. This is diving in the deep end, just for the record. I want to show it to you because, well, it's good to finish everything in the book. I've never seen it before, and it's good to make sure we do things correctly. But then also, it's good for your brain. It's good for your brain to think about things this way a little bit. So here's what we notice. I actually have b minus b, which doesn't matter what b is. Anything minus itself makes 0. I also have mx minus mx. So I end up with change in y equals m times change in x. Well, that's much prettier, much simpler. Now, a cool thing about stuff like this is when we start thinking about letters as actually representing something, this means something. Okay, one thing we can do is I can divide both sides by change in x. And that gives me the change in y over the change in x equals m. How is that cool? Well, I told you what that was. What does m represent? This is just a formula for slope. Now, you could pick apart a little bit of this and say that it's what we call a tautological argument. That is not where we're going to go right now in our class. So we're just going to say, hey, that's cool, and we're going to go on. We're not going to try to address whether it's tautological or not, but it's kind of neat. Okay, so consider the function f of x equals 12x minus 24. Can you find the 0 of this function? Okay, so we have this guy. What is the 0? Well, that's an important thing to understand. What's the 0? Well, 0 is x equals 0. Pretty easy, huh? Okay. We'll say of a function. Okay. So we're going to find where x equals 0. That's what we're going to find. Well, that's easy enough. Oh, no, I did that wrong. This is not x is 0. I'm making tons of mistakes today. I'm very sorry about that. This is where f of x equals 0. Okay? Where the line gets down to 0 right here. So we want this to be 0. So guess what I'm going to do? I'm just going to make it be 0. 0. Sorry, the y-intercept is when x is 0. The 0 is when f of x equals 0. Don't you love just the tangle of different possibilities? So what am I going to do to both sides of this equation? We're going to practice this both sides of the equation stuff a lot in the next couple chapters. So I'm just going to remind you, we add 24. We have to add 24. We end up with 24 equals 12x. Well, let's see. What does that mean? Well, if I divide both sides by 12, I get, well, what do I multiply by 12 to get 24? X equals 2. The 0 is x equals 2. So what the heck does that even mean? That means that we'll say right now, this means that if I plug a 2 in for x, the function should end up equaling 0. Equal to 0. Equaling is not a great word. Okay, so great. Let's try that. So if I plug in a 2 for x, so that means I'd have f of 2 equals 12 times 2 minus 24. Okay. Well, that's 24 minus 24, which is, you guessed it, f of 2 equals 0. F of 2 is the 0 of this function. If I plug in 2, I get 0 out. That's what makes something a 0. Hopefully that made sense. Okay, we're to this bit. I'm going to do these ones quick, all right? I'm going to do these ones quick. I'm going to really quickly make this guy here. I'm not going to talk too much. This is going to go onto your quiz, okay? This is going to be one of our quizzes. So you're going to have to be good at this stuff. Also going to be very common to have this in a test. Why? Because being able to look at a function and quickly graph it is so important in later math, okay? So let me really quickly cut and paste this, Control C, Control V. We'll put these guys so that they're nice and boom, and Control V. I notice all of these numbers are like 1s, 2s, and 3s. So I am counting on the fact that this graph will work because all my points are, all my directions on this graph, I can count to at least 3. Okay, so here are my steps. You're going to have to be able to do this fast. This is y equals mx plus b. Let me try it. Y equals mx plus b. Here's what I noticed about this one. M equals 3. And b equals -2. That's what I noticed about this. In fact, I would like you to type that in. Now, I just need to make those things happen. I'm going to start with b, -2. That's right here. Ooh, how did that happen? Okay, well, I'll type that in a moment. And then this guy's goes up by 3. I end up with, oops, I made a mistake. And there we have our, wait, that's really weird that it's, I made a mistake twice. This guy right here in the wrong spot, so is that. There, now it should work. There, now all the points line up nicely with it. Great. Okay, so here's what you can do. You can say, Control Z, I don't want to do that here. B equals -2. And here we have m equals 3. Okay. That's what I would like to see. Notice 3 up. I could say 3/1 if that helped you see both numbers. Okay. So we're going to go to this one. This one has m equals -2 and b equals 4. We'll do this one faster. Okay. B is at 4, 1, 2, 3, 4. M is down 2, down 2, down 2. All I'm doing is noting for every 1 it goes to the right, it goes down 2. That means if I go left, it goes up 2. Okay, so there's my graph. I'm going to change this to a 2. Really quickly draw in that graph. Boom. So here we have B equals 4. I should probably use it as lowercase b. B is always lowercase. And then 1, 2. Notice that the y is how I keep track of going up or down. I always count to the right. Y for m equals -2/1. Right. Hopefully this is making sense. All of them I solve exactly the same way. -3. Well, that's going to be my y-intercept, -3. So I'll go down to -3, 1, 2, 3. In fact, I'll put in this y-intercept as well. That one's +3, 1, 2, 3. Next, I need to notice this. This means up to, oops, too big. 2 and over 5. That's an arrow, by the way, there. Okay, so let's go up 2 and over 5. Up 2, 1, 2, 3, 4, 5. Going back the other way, it'd be down 2, and 1, 2, 3, 4, 5. There. So this is going to go like so. And we have b equal to -3. And up 2 and over 5. That's how we graph it. This one needs to go, notice it has a minus. That means it's going down. So it's going to go down 1 and over 3. So down 1 over 3, down 1 over 3. Going the other way. And we got our graph. This is an incredibly important part. Well, I mean, important is a funny word, but it's a very central part of math in high school, being able to do this easily. B equals 3. And this goes down 1 and over 3. There we are. Okay. Reinforce, write a function rule and construct a graph. Let's make one up. Okay, let's do one with small numbers so it fits on our graph. I still have a oops. No, I don't want to do that. Control Z. I don't even know what that was. Actually, what if I do V? I think it should work, right? It's not. Okay, great. Let's just type in and make this happen. Okay, y equals mx plus b. I would love you to make up your own. I'm going to put in the numbers, I don't know, -3/5 and 4. 3, 5, and 4, that'll be fun. Y equals -3/5 x plus b. I will say it's nice to put parentheses around this because then it doesn't look like you've got a 5 and an x on the bottom of the fraction. It's a very common mistake people make, but no, we have 3/5 times x. You could also just type it, write it in. All right, I forgot the b, that's going to be 4. Okay, so what am I going to do? I'm going to graph it. Now notice, if you wanted to graph it the old school way and plug in some numbers, you can do that. That's no one's stopping you. But I will say, it takes a lot more work. Once you get the hang of this, this is a much faster method. Is just understanding what this graphing, what this function is talking about. And instead of having to just plug in numbers and see what happens, you can look at it and know what's going to happen. I know, for example, that if I plug in 0 for x, oops, I plug in 0 for x, I'll get y equals 4. Now you can go through that and find out that that's true. Perfectly okay. But I guarantee you it's true. That's the y-intercept. So I could graph the point 0, 4, right? That's this point right here. Well, we already knew that was going to happen because 1, 2, 3, 4 is right here. Boom. Oops, gotta make it the right size. 4. There. Because this is b equals 4. Okay, and the next thing I can do is I can put in a number that cancels out with a 5. So if I put in 5, x equals 5, then the 5's cancel out, I get -4, I get 1. If I plug in a 5, you can plug this in if you want. If x equals 5, then y equals 1. I guarantee you that's true. 5, -1. Now I can plug it in and I can do all of that math. Or I can just notice, and here's how I picked that number, because I have done math before. 1, 2, 3, 4, 5. And here's my graph. There's my graph. And I notice if I actually just figured it out by going down 3 and over 5. So you can do it the old school way and plug in numbers and figure out the answers and plug in this. No, these points are here and then like the line and all that. It takes a while. Or you can realize, hey, it starts at 4 because of this, and it goes down 3 and over 5 because of that. And you're done. That will work for anything in this form for the rest of your life. Great. Write a story for a situation that can be modeled by the function rule you wrote in the previous thing. Okay. Let's see. 3 and 5, I didn't realize I was doing this. Ugh, bummer. Okay, so what's going to happen is he has $3. No, he has $4 to start out with. And he is really good at video games, and it takes him $3. After $3, he's been playing the video game for 5 hours because he's so good at it. That's what I'll say. Or she. We'll say she, because girls play video games too. Anna He was really good at video games. She goes to the arcade with $4. I'm really, really typing great. After 5 hours of playing, she has used up $4. There. You could figure out how many dollars per minute if you wanted. You could do a little math and figure all that out, but no need. We could turn them to quarters instead of dollars, because that's usually what you play with in an arcade, at least when I was a child. Okay, so that's that. Now we're going to graph the following functions. Hey, more of this. Slope is 2, y-intercept is 6. That's all there is to it. Let's do this. We're almost to the end, my friends. I know this seems like it takes forever, and it kind of does on a computer, and I'm sorry about that. But at the same time, it's important to get this right. So -6 is 1, 2, 3, 4, 5, 6, 7, 5, 1. Let's mark that with a 6. That one? 1, 2, 3, 4, 5, 6. Very good. Actually, no. I'm going to copy and paste this because it'll save me time. Boom. Control C, Control V. There. Control V. And then Control V. Is there another one down here? No, those ones are done. Great. Back to graphing. We were at -6, which is right here. You know what? I'm going to mark all of the B's, the intercepts first. 3. This y-intercept is -1. This y-intercept is 5. So now I know where they go through the y-axis. Now I just have to talk about how steep they are. So now we'll do that one in purple or something, yeah. So for every 1 it goes to the right, it goes 2 up. 2 up, 1 to the right. That's what's going on there. So 1 to the right, 2 up, 1 to the right, 2 up, 1 to the right. You can always remember, if it's just a counting number, it's still a fraction. It just has a 1 on the bottom. That means for every 1 to the right, it goes that many up or down. This one, for every 1 to the right, it goes 4 down because it's negative. So 1 to the right, 4 down. 1 to the right, 4 down. 1 to the left, 4 up. Great. That line goes steeply down, like it says that. This one goes 3 up or down, 4 to the right. Well, it's up because it's positive, right? So I got to go 3 up. Uh-oh, that's going to go off this thing. I'm going to go backwards. 3 down, and 4 backwards. There. Now this one goes over 4 and up 3, over 4 and up 3. Those are the only 2 places I can make it work, though. Okay, this one goes down 5 and over 3. It has a negative. So down 5, 1, 2, 3, 4, 5, and over 3. Over 3 and up 5. Because I'm going backwards, it's okay to do that. All right, so now I just got to put in my graph lines, and I'm done. Change this to a 2. There's that one. There's that one. This one I'm going to have to do it in 2 parts because it doesn't have very many points. Go this way. Go back that way. Now it's a solid line. Kind of same with this one. I'll go like this. And I'll go back. So there we are. Okay, so I have those graphed. Hopefully they make sense. Last ones. Write an equation for this. Now we've taken equations and turned them into graphs. We're going to do the opposite now. So we have to find the slope and the intercept. Slope and the intercept. Okay, notice. Here's what I notice when I look at this. We have a table. We can use that to find the slope, or we can use this to find the slope. Either will work. This does not have a 0 for my x, so it's going to be easier to look at the intercept right there and say, hey, this crosses at whatever point. So let's take a look at this. This crosses at 2. Our intercept is 2. Okay. I'm going to make this be red. I'm going to say that this is actually, we're going to fix this a little bit. I'm going to go back to the text. Slope. I'm going to erase this guy. Wow, I can't seem to type. Oh well. Okay, so there we are. I'm going to go down here and I'm going to make this one red so it matches. Intercept, or I'll say y-intercept. Hopefully you're bored by now and you just have already typed it in because you know that it crosses at 2. Okay, now we're going to go back to the other one. We're going to find our slope. Let's find our slope now. Boom. We're going to go with writing and we're going to turn it purple. Notice this guy changes by 2. This guy changes by 6. Wait. These are different. I wasn't even looking carefully. These are 2 different things. Okay, so let's just really quickly fix some things up. So these are 2 separate problems. I don't know why they didn't just make them 2 separate problems. I'm sorry about that, but that's just my bad. Okay, so let's do this. Move you down here. We're going to move you down here as well. And then we'll do the answer down there too. Okay, and I'm going to fix this right here. Sorry about that. Ugh, there's always something wrong, I feel like. So this guy's right, wrong color. So we know our intercept is 2. The next thing we need to do is find our slope. Notice this goes down and over it goes down 1, 2, 3, 4, 5, and 1 to the right. So the slope is down 5 and 1 to the right, which is just negative 5. So the formula for this would be y equals m is our slope, negative 5, x plus b is our y-intercept. And that's it. Okay, let's move on to the next one. Here's what we notice. This goes up by, do purple for slopes. This goes up by 2s each time, right? This goes up by 6s each time. So slope is always y over x. That's going to be 6 over 2. Or 3. Okay. Actually, I'll do that because it's much cleaner. But finding the intercept, how would you find that? Think about that while I type. How would I find the intercept? Slope equals 6 over 2. Okay, well, if I go backwards, This changes by 2's, right? So that's going to be, what's going to come next? 1 and 0. I don't want y to be 0. I want x to be 0. So I need to go back to 0, which means that this would actually have to be, that's only moving by 1. So this is only going to move by 3. I get that. Notice that that follows the pattern. This is going down by 2's, that's going down by 6's. If this goes down by 1, half as much. This goes down by half as much. And there you go. So I end up with this. This is my y-intercept. So I'll do that in red. Now we're going back to text. I'm going to make you back to purple because that's what we're using. And then, oops, no, not yet. And that's intercept. -3. So my formula should have those two numbers. Y equals mx plus b turns to y equals 3x minus 3. They're both, this one's -3 and that one's +3. So here's my +3 and my -3. So I got that. Let me really quickly just circle these. Oops. Okay, these ones. Now this one also has my y-intercept right there. You can see it. It's at y-intercept equals -4. 4, 0, -4. But I'm writing it two different ways. That's because often people forget that the intercept's not just a number, it's a point on a graph. So remember it's a point on a graph because sometimes in tests you get asked for the intercept and they ask for one version or the other. So if you're in state testing one day, not that you'll have to do it this year, yay, but they might ask for it either way. And it also helps remind you that x is 0 at the y-intercept. Okay, the next thing is we need the slope. Notice the slope, let's see, it's going to go, oops, no, I don't want that to be red, I want this to be, okay, boom, boom, boom. Goes up 2 and over 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 to get to that point. Yep. Okay. So that's my slope. Is x over y, so that's 2 over 6, or 1/3. Okay, so if I'm going to do this, it's going to be y equals mx plus b, which when I put in the numbers is going to be y equals m is my slope, so that's 1/3. I'll put parentheses around it so it's very clear. That's my m plus, oh, minus 4. And there we go. Answer. Done did it. The last one. This one's a little tricky because notice these ones with the graphs where I see the intercepts are nice. Did you notice this one took more work? This one will also take more work because they're not telling me the intercept. Some of the later forms we're going to learn later in this chapter are specifically to deal with that. So let's take a look at these. We've got 10, -2, and 15, -4. Where are those on a graph? Just as a reminder, 10 is going to be way over here, and -2, and 15 is going to be -4, like that. So you're going to have a graph that's like this or something like that, right? Or like, yeah. So we've got something like that. We have 10 -2s right here and 15 -4s down there somewhere, right? So that gives me a sense of what's going on with my graph. How can I figure out the things for this? Well, I'm going to show you another trick right now. We're going to use some algebra this time. This is a cool way to do it if you have 2 points and you don't know point slope form, which you don't know yet. You're going to use y equals mx plus b. And we're going to find out one of the numbers. We're going to find out our x's and our, well, can we find our slope? We should be able to with 2 points, right? The x, let's see this, Control Z, Z. Oh, I didn't want to do that. Whoops. I'm going to erase this. So if I don't have a graph, here's a cool way I can do it. So we're going to find our slope. X adds 5. All right. Now y, on the other hand, takes away 2. Y takes away 2. So we know what's going on with x and with y. That's how we can find slope, right? Slope, oops, equals change in x, or sorry, change in y, or change in x. How much did y change by? It went down 2, from -2 to -4. How much did x change by? 5. It went up 5. So that's my slope. Okay, so here's the cool fancy way to solve this. All right, you're going to love this if you're an algebra person who likes to do things like plug the numbers in and stuff. We're going to use y equals mx plus b. Y equals mx plus b. You might ask, is this the right way to do it? There's no right way to do this. You just have to solve it, right? So if you graphed it and you figured it out, oh yeah, that's the y-intercept, or you thought back in your head, so if it goes down 2 for every 5, it goes to the right, and I go back the other way, I can figure out that it goes to 2. The y-intercept is 2. You can figure that out. You can by visualizing it in your head if you're a visual person. This is another way to do it that we're going to do because it's good practice algebra. So -2/5 x plus b. Okay. So now what do I do? Well, the cool thing is I can tell, I know an x and a y that work in here. And as long as I have only one variable, I can solve for it. So what I'm going to do is I'm going to take one of these guys and I'm going to plug it in. It doesn't matter which one. I'll use the 10 and the -2. Okay? So I'm going to go here. I'm going to, oops, no, I'm going to take this, make it go down here. And I'm going to turn the x to a 10 and the y to a -2. So let's do that. Y is a -2. Cool thing about this is, algebraically, we have all of our numbers there, except for the b. So as long as I can multiply this out and figure out what it makes, I can figure out what b is, what my y-intercept is, not without even seeing a graph, without knowing what's going on. I can figure out what b is, because I know everything else, and I can use algebra to figure out what's left. So when I multiply 2/5 times 10, I get 20/5, which is 20 divided by 5 is 4. So this actually makes -2 equals -4 plus b. That's what we get. What do I add to -4 to get -2? Well, if I want, I can add 4 to both sides. I get 2 equals b. What does that mean? Well, that means my y-intercept is b. It's 2. There we go. So I have my slope. Oops, I didn't want to do that. Slope is -2/5. I can't spell. Intercept is 2. Y equals -2/5 x plus 2. There are a million ways to do that. If you prefer figuring it out by graphing it, do it. Okay, I could say, hey, this goes down by 2 every 5 it goes on. Every time this changes by 5, that changes by 2. So if I go back, I could get the point 5, 0 and the point 0, 2. That's another way I could have figured out that the y-intercept is 2. But that's only if you like doing it that way. There are lots and lots and lots of ways to solve math. Get excited about that. Okay, hope that helped. It's a lot of problems. That should be 2 full days of class. So good job. I'm stopping.